everybody is here. We are starting recording. We wanted to share why we do this because we have this on the mindset of LinkedIn of doing sharing, and we do this regularly with the club days that we have every 2 Fridays internally, with the meetups that we do via IT Next, with the conference that we do yearly, and with the itnext.io website. But since the coronavirus started and we have to all work remotely, it became a little bit trickier, especially to have this kind of sharing that involves our clients, potential clients, partners, because that's what we like to do, share things. So we decided to start with this breakfast sessions. We had one for OutSystems a couple of months ago that was really nice. So we decided to do this one. And for those that know LinKit, I think the majority of you know, for 22 years now almost, we exist here in the Netherlands and other nearby countries as well as Germany and Scandinavia now, as a company that for a very long time did extremely well data sharing sourcing. And for this last years, we also started doing something else as providing solutions to clients. And that means that we can also help companies that have a specific problem, and we can help them sort it out with people like Krisha, Maaike, to provide a solution for them to move forward with it. And we build that in a very nice way with some clients that we have. And specifically on the data part, that's one of the focus that we have. We already done and implemented and work within solutions at ASML, Nike, KLM, uh, Bol.com, Picnic, and some other places. So that's one of the areas of expertise that we have. And we wanted to show that, inviting ASML, inviting people from Axual, our partner that has this amazing platform, and with Alyona, one of the principal data engineers that we have. So I hope that you enjoy now on. And again, just like Kisha said, if you have any questions, write in the chat. And after the session as well, please reach out, add the people that you want via email, LinkedIn, or something, and let's continue sharing. So I'll give my floor to Krisha back. Thank you. Move on.
You can raise your hands.
Raise your hand if you're back.
Everybody's raising their hands.
Oh, yeah, great.
Oh, look at that.
It kind of works. Yeah, well then I think we can start with I will stop raising my hand at the moment, and I think we can start with the presentation of Axual.
All right. Right. Can you see the screen?
Yes.
Yes. Okay, good. Good morning, everybody, and also welcome to the session. And thank you for LINKIT to organize this session also together with us. I think it's a great opportunity to tell you a little bit about an exciting new technology called data streaming. So in this presentation, we'll give you a little bit of an introduction on what streaming exactly is, and we're going to give you some example use cases and also a demo, which is really something of a use case close to our current situation, but we'll go into that in a little while. So first, let me give you a little context on data streaming itself. Well, you saw in the example of ASML already that well, it comes as no surprise that organizations operate in data-rich environments, and exactly where ASML is experiencing the data pressure is also where other organizations are experiencing the data pressure, namely at the edges of the organization. And you have a number of edges, right? So you have edges on the customer side, where all the channels are, where your customers are interacting with your company through apps, shops, and websites. But there's also a supplier side, where your suppliers and your business partners are located, and they give you price updates, delivery times, location updates, status changes of orders that you placed, anything that you interact with them about. But then again, that's not all. There's also a lot of internal sources. And I guess the machines of ASML could be seen as internal sources, because even though they're located at different sites, it's their machines emitting all kinds of sensor values, emitting events. But think also about internal applications of bigger organizations like governments, banks, energy companies. They have applications running that may process transactions or may execute some BPM process. These all emit signals that you need to deal with as an enterprise. And then again, there's also a lot of external sources that give you all this information about social media, where your customers may be talking about you, news sites updating about you, weather information that you may need to incorporate into your business, broker information from markets, and also governmental information, for instance, the updates of citizen information or business information. And what you see enterprises structurally do is they start to organize this data pipeline to handle all the inflow of information. And what they typically do is, well, first they collect and ingest the information, they filter it somehow and adjust it to the proper format for further processing. And then they start interpreting the data, associating it with other types of information that's already present in the organization. They can process it and calculate maybe some alternative options. And once those options are there, you can weigh them, you can see what's the best course of action, and you can decide and plan your next steps. And typically, this whole cycle of information influx and how you process it is speeding up. Where it used to be batch, is also what you saw in the ASML example. It used to be batch, but now the need to become more real time is growing. For instance, with customers, you need to process their information more quickly because they demand quick responses. And also the sensor information that you get out of your networks needs more speed in processing. So this whole pipeline of influxing the data and handling it quickly, it's speeding up. So what is data streaming? It's the technology that makes this all possible. Well, actually, a data stream is not that complicated. A data stream is an endless list of messages, and then with a certain name. In some technologies, they talk about topics, others have other names, but basically the stream is just a list of messages. And when you produce a new message, so a new data item pops up on a sensor or on some other channel, then what that producing information, the producer actually does is to append it at the end of the list. And it will always append it at the end of the list. So you get a list that is time sorted with similar kinds of messages. And here in this case, the example is infection reports, and it's something that Joris will go into more depth in a little bit about. Well, such a stream can have multiple consumers. And here you see two drawn, consumer A and consumer B, and they can be at different places in that whole list. So consumer A is lagging a little bit because he's further away from the end. And consumer B is relatively up to date. When message 12 gets produced, he immediately can consume that because he's already at that position. So streaming itself is not so complicated. It's actually just the continuous collection and processing of all these events that come in. All these data items, usually they're events describing something that took place in the real world. These producers and consumers, they typically do not know each other. So what happens is that the consumer gets the message and takes it as is, but does not confirm anything back to the producer. The producer's job is done when he reports the event to the platform. So consumers are notified of the new data items coming in, and they do not reply, but they can respond by executing some meaningful action. Now, the execution of those actions can take place at different times, and here you already see the connection back to batch. So if you process the event just after it gets created, then you talk about event-driven data processing. If you do it maybe once every hour or once every day, just shortly after, then it already becomes batch processing of recent data. And if you store all that data in a data lake and you process it after maybe a month or a year, then you talk about the batch processing of historical data. So the really batch and streaming are really close by. What you can think about streaming is that it's the continuous processing of batches of one. So what happens during the communication of these applications, the producer and the consumer say that the producer wants to notify or detect some event and wants to indicate that to the rest of the world. Then he makes a message, puts it in an envelope. That message then gets translated into a series of bytes, and those bytes just get put on a streaming platform. The platform makes a copy of that, and then to every consumer that wants to get that message, sends off the bytes. The consumer then knows how to decode those back into the message, and the consumer would be able to handle the message. So basically, this is what's happening continuously, and then at rapid speeds and possibly a very large scale. So the server only sees bytes passing through, and it holds a copy for other consumers that may also be interested in the same message. So the producer does not need to put a message on the platform for every individual consumer. It just reports it once, and then multiple consumers can use that message. So what is a streaming platform? If you scale this up a little bit, and I've drawn here a picture to indicate how it might work in a bigger organization with every department connecting around a streaming platform, then the streaming platform really becomes like a marketplace where all these applications of the different departments can exchange business events at the moment they occur. And a business event can literally be anything, depending on what type of business you're in. But it's something that took place in the real world that another part of the organization may want to respond to. So I'll get to a few examples in a little bit. So typically there are three types of interaction patterns with such a platform. You have producers. They detect some sort of an event that took place in the real world, translate that into an information package or a message, and put that on the streaming platform. The consumers, they know about certain stream names, so they can subscribe to certain streams. And then every time a new message gets produced on that stream, they can see it right away and process it as they see fit. And then there's a special type of application called streaming applications. And what those typically do is they consume from one or more streams and they produce to others. So think about an anonymizing application. You may have a stream containing all sorts of credit card transactions. So you may have a streaming application that consumes these messages and then converts the credit card number into a series of access and then produces the message on yet another stream, which is then the anonymized credit card transaction stream. Now, typical examples, and we have customers in the banking world. So this is an example of how it would be handled in banking. Say you have a customer birthday. This is an actual use case that we had with one of our customers, whose logo is already nicely shown in the background. But they had a case where customers turning 18 need to report back to the bank because they are not a youth anymore, but they're an adult now. So they have to report to the bank, but that often doesn't happen. So what they did is they made an application that reports all these birthdays every night, and automatically when a customer turns 18, they transform their adolescent account into an adult account, and that gives the customers about 6 months more time to come to the bank and identify themselves, and it doesn't need to happen exactly on the day that they turn 18. This is really a useful case because it saves the bank about 200 customers a day that used to become, illegal customers because they had products that they couldn't officially have anymore. Another example, it's also a nice one, is the payments on your payment account. If you have a payment account with a bank, then you have bookings on that indicate, half of the transaction. It's either a credit booking or a debit booking. All these bookings are being put on a streaming platform, so there are transactions that took place at a certain point in time. So what happens is that one consumer would be the personal alert generator that could indicate, that two customers on push SMS or email that something interesting happened on their payment account. But another consumer would be fraud detection to see if nothing illegal is taking place, like terrorist financing or money laundering. And yet another example would be customers logging in. Usually when you're on a website and you're not logged in, you are indicated as some anonymous visitor ID. But once you fill your basket with some products and you want to get those products, you have to identify, and sometimes you're a customer already, so you log in and you become a known user ID. Well, these two need to be tied together in order to analyze the full customer journey later on. And this is what really happens in the customer login event. So your user ID and your visitor ID are tied together, and that's been put as a message on the platform along with some other details, which goes to the marketing engine for further analysis, but also to fraud detection, to detect if people are logging in strangely or strangely much. So with these examples, I would like to hand it over to my colleague, Joris Meijer, who's going to give you some other example of how you can use streaming in a current situation. Joris?
Thank you, Jeroen. Let me first share my screen. Let's see. I hope everybody can see it. Can you see it, Jeroen?
Yep.
Just using you as a guinea pig for now. All right. So indeed, Jeroen already mentioned, I want to give you a demo that is, very much related to what's going on currently. The whole Corona situation and let's say crisis that happened as an effect of it. So in this demo, we will show you how Axual can help you to simplify data exchange between applications and multiple stakeholders while staying in control of your real-time data. So to make the demo more illustrative, we've come up with an actual example, a real-time COVID-19 dashboard for the Netherlands. So the National Institute for Public Health, we all know it as the RIVM, is the organization which is the subject of this demo. It wants to offer a real-time overview of Corona cases reported per municipality, and it wants to be able to advise on relocating patients based on the hospital capacity in every province. So there are multiple parties involved in both gathering the data, aggregating and processing it. In this case, I will share it in a diagram in a couple of seconds. And the COVID cases are reported to the public health services, known as GGD. And currently, this data is only reported on a per day basis. But of course, when a crisis is going on, you want to be aware of the situation at all times. And having a report just every once per day is not enough. So for that, we created a simulator that simulates Corona cases in all municipalities of the Netherlands. So here you see the architecture of the demo. And in the top of the screen, you will see the actual cloud environment that we're using currently for the demo. In the bottom part, you see the organizations and the parties that are involved here in this demo setup. So there is one team responsible for reporting. In this case, the doctors are responsible for reporting the Corona cases to the system. Let's say today, is responsible for creating a dashboard that provides insight in the current situation in the whole country. And there's another party, the outbreak management team in this case, aggregates all the data that's coming in from all the COVID cases in all the municipalities, and takes into account the capacity in the different provinces, and is able to alert the capacity coordinator, it's a fictional person, to make sure that he can make sure that let's say new patients are being routed to a province where there is still enough capacity. I hope the context is clear for this demo. Of course, to not keep you waiting too long, we have prepared some of the things already before we started. So I've shown, what I can show you here is a dashboard where you can see that some of the data streams have been prepared already. So the alerter and aggregator app here that's run by the outbreak management team is already prepared. It's waiting for, let's say, waiting for infections to happen. It doesn't sound very nice, but that's the main interest of the outbreak management team. And it has some data streams that are used to do the alerting based on capacity and limits in particular provinces. So we now need to make sure that the infections can really be reported. So what I will do, and the reporter app needs proper permissions to do that. What I will now do is create a request to produce data on the infections stream. In this case, you can imagine when you're in a larger organization, you want to be in control of who produces and consumes data to and from your data streams. For this demo, I will just approve the request right away. So it's just one person providing the access. Normally that would be the data owner. You can now see in the overview that the infection reporter here has access to the infectious data stream, so that in theory that would already bring some data to the aggregator or alerter app. So the simulator is already prepared. It's running. What I can now do, I mean, this is let's say the pre-COVID situation, so I think roughly January this year. I don't know. What I will now do is start the simulator with one case happening every second throughout the country. So what we can do is to validate whether it's working, we can switch to the stream and we can see in real time that the events are coming in. So I'm performing a search query here. You can see that in a random in random municipalities, infections are happening. In this case, the payload of the message is the timestamp, the gemeente, municipality, and the province where it is happening.
Joris, can I quickly? There's a question if you could enlarge your screen a bit.
Yeah, sure. One moment. Let me find the chat. Enlarge your screen. Yeah, sure. I can try. In this case, the browser, I guess. Is this better? Let me see. Check the chat. Okay. Cool. I can maybe zoom in a bit to make it better. Okay. All right. So you can see that the cases are coming in here. And indeed, the dashboard has been prepared already. I think some of you already saw it here. And what you can see here is that the cases are coming in the different municipalities. We say Nieuwkoop, some infection, or Oost-Stellingwerf, Apeldoorn, a couple of infections. So what I will move on now is to the next part. what I actually did not do yet now is enable access to the dashboard application. I think it has been, that was already done. No, need to make sure that the dashboard has proper access to the data. Here we go. All right. So what we can now do is we can simulate an outbreak in a particular region. Of course, if you want to be in control when something bad happens, you want to respond accordingly. So we will now simulate an outbreak in the region Apeldoorn. So I prepared a demo set for that already, which gives a bit more weight in the region of Apeldoorn and in this case the municipalities around it. So let me have a look at the dashboard. You can already see that it's, let me verify it's running. Yeah. So you can see that in Apeldoorn and the municipalities around it, the cases are growing, the number of cases. And we'll zoom in a bit. And you can see that the dashboard and the table to the right, to the top right, is updated automatically. And what is now going to happen is that as soon as the capacity of, in this case, province of Gelderland is approaching a certain limit, we've now set the limit to 80%. So the capacity used in this case, when it reaches 80%, it will send out an alert to the capacity coordinator via Telegram. So what I can do to not keep everybody waiting too much is we can increase the frequency a bit so that the number of cases will grow more rapidly. 69, 71. Yeah, almost there. I hope this should. I expected an alert to be sent. This is the demo effect. So I expected an alert to be sent from in this case the province of Gelderland, where the capacity was going past 80%. I don't know why it is not coming in, but yeah, let's blame it on the demo effect in this case. Basically, that was the demo that we wanted to show. Data is coming from multiple parties. In this case, the doctors reporting the cases to the GGD, which provides a dashboard to people that can interpret the data more easily, see where situation is becoming more critical, and also respond accordingly. Sadly, the message was not being sent. That would have been really nice. But I hope the demo gave more insight in what streaming can mean for you, and also what the features that our platform provides to be in control of your streaming data. So I want to give the word back to Jeroen, and I can tell you more about other use cases of real-time data streaming.
Yeah. All right, well, thank you, Joris. Yeah, so what was really nice in this example is actually the second use case that I'll get to in my next slide. But we see a lot of different use cases coming up currently with all kinds of different customers in different sectors for data streaming. So the first one is actually what I showed initially, everything around customer service. So there's data flowing in from websites, from customer channels, from bol.com if you're a vendor there, Everybody wants to create their own 360 views to understand the customer better and to interact with him in a meaningful way, but also in a real-time way. So it's really important to understand the customer and to take in every signal that he gives and to incorporate that into your view of that customer to be able to understand him better and to give him a good advice. The second use case on this slide is actually what Joris was showing. We see a lot of uptake currently about ecosystem integration. So different parties coming together on a single platform to exchange information. So here you can also see that the doctors and the GGD, but also the outbreak management team and the RIVM, they're all independent organizations, but they want to exchange meaningful information about a certain in a certain domain. And what they do then typically is connect to a central platform and exchange the information that they can. So doctors are expected to provide infection reports, and then, that's the only job that they have. And then they turn back to their patients because they need attention to give attention to their patients. But then using those infection reports, the GGD and the IVM, they can play their own role and they can, try to come up with dashboards, with predictions, all kinds of things that they need to control. So they use the doctors in the field as sensors on what's going on, especially around COVID-19 in this case. And you see the same thing happening in airports, in harbors, where a lot of different companies are coming together on a single platform to exchange information about a certain business process that's going on. The third use case that we see is the speeding up of batch processing into real time. So what I said earlier, in most business processes, the speed is picking up, and batch processing is turning into continuous processing of batches of one to fulfill the real-time demands. And you can think about real-time, dashboards, fraud and anomaly detection, and all sorts of request processes that are being sped up in this way. And last but not least, everything that revolves around sensor data processing. So there's loads of companies with a lot of sensors out in the field. Think about, railways, energy companies, digital grids, smart cities. ASML was also a terrific example earlier on. All their machines emit huge amounts of data, which need to be processed more and more in real time. Now these sensors, they're really emitting that data, and business processes pick that up and start processing it right away. So as soon as you have these use cases, you'll want to see how you can integrate streaming in your organization. But that's when we experience that the real challenge also starts, because just putting a streaming platform in an organization is often not good enough. Because as soon as you start doing that or designing that, then you'll run into typical personas inside your organization. For instance, such as data owners, and data owners, and think about data owners also as the persons responsible for guarding the GDPR. They want to be in control of streaming data at all times because they have this formal responsibility that they want to somehow manifest in their job, and needs to be boiled down into the platform to give them that control. IT architects, they are really interested in buying a future-proof and secure platform. Then you run into developers, and developers, they have a bit of a weary history with integration platforms from the past, because in the past they used to integrate a lot with ESBs. And what they found out is that there's only a limited set of people in the organization with knowledge about what an ESB can do and how it should work. So often if you need something done from the ESB, you need to turn to the ESB team. But often these teams are so overloaded with work that you can come back in 4 or 5 months and then they can maybe help you. But in the meantime, they're just too busy. So developers are really, anxious for integration platforms, and they want, if you want to put a streaming platform in the organization, they want to still be able to work quickly and independently of anybody else. And then operators say, well, I want a predictable and maintainable system, of course, because they don't want to be called out of bed at night. And procurement is really interested in working together with credible vendors that the organization can rely on. Now, all these needs, they translate into typical requirements like these. So data governance, schema management, end-to-end encryption, a hybrid cloud, self-service for DevOps teams, CI/CD support. It's really all these kinds of requirements that you see around the streaming platform when you implement it in a bigger organization. And this is exactly what we decided to base our platform on these requirements. So what we did is create a full stack that supports all these requirements by building upon a generic infrastructure with Docker and Kubernetes. We put a streaming platform on top that handles everything around the technology. And also the team that manages this part of the platform is only focused on technical maintenance. So they monitor the performance and availability. And what we did is put the self-service interface that Joris just demoed on top, so that anybody in the organization can log into self-service, define their own data streams, define their own messaging schemas, and handle everything around security. So it's really the data owner in our platform that logs in and sees a request from an application to access his data, and then the data owner can decide on whether or not to allow that application to see his data. If at any point in time he wants to revoke that later on, he's also free to do so. And it's really through that self-service that not only the data can scale in your data platform, but also the organization around streaming can scale along with the platform. Because use cases, they really manage themselves by the team that implements the use cases. There's a whole bunch of features associated with everything around that platform. We'll be happy to tell you a little bit more about those if the time is there. But in short, streaming is really on a technology level, it's really a complex business. Well, we see a lot of organizations struggling with that. So this is really what we made our business about, to make streaming simple. And basically what you can say is that we want to put every organization in the data driver's seat. So that means that you are in control about what happens on the platform and how fast your organization can adopt streaming. If you use a streaming platform, then what it really enables is to create and to generate situational awareness throughout your organization. And with situational awareness, I mean that you all have the same view based upon the same data. It's really annoying if some part of the organization is looking at different data than you are, because they're bound to make different decisions that you would. And this is really unproductive in executing upon a similar strategy. So by being better informed and in control, we think our customers will interact better with their customers, business partner, and markets. And we also defined what we call a BHAG, which is our big, hairy, audacious goal, because we think streaming should be so simple that our customers should be able to bring a new streaming use case to production every day. If you wake up and think about, this will be really cool, and what if we can, use this type of data and combine it with that data and maybe get some great results. If you think about that in the morning, in the shower, you should be able to, work on that during the day. And if it turns out to be something that really works, you should be able to bring that to production in the same day. Now, in order to do that, we provide a platform in two ways. So you can have a license form to deploy it on premise, and we also have a cloud version that takes away all the pain from managing it yourself. and you have a SaaS installation. So what, in short, summing it up, what data streaming allows you to do is to build that collective situational awareness across your organization. You can interact more personally and more directly with your customers, and you can act faster on changing circumstances. Also, a big plus for streaming is the benefits that you get in your IT landscape. It provides flexibility for your applications, because applications that connect to a streaming platform can be taken, offline at any time and come back sometime later. So this also decouples applications in terms of time, because the sensor information that's being produced on the platform is just stored there for some time. If your application goes offline and comes back, it can still consume all the messages that have been produced since it went offline. Also, the whole landscape becomes more flexible because you talk about data contracts and not about API contracts. So this makes applications easily replaceable and changeable. So what we usually say is you can think about this as an hop-on, hop-off, like a tourist bus, that applications can connect, hop onto the platform and hop off at any time in the future if they need to. Well, you're always in control. The governance and security is something that we deem crucial for enterprise adoption. So this is really built into the platform. It gives you full control of the people that have responsibility. So DevOps teams, they can define their applications and request access to data streams. Data owners can allow or revoke that permission later on. And you have full audit logging for reproducibility of certain incidents. So you can, especially with the cloud version, you can start small and scale later. There's pay-per-use pricing available, so you can grow your data streams and your organization around it as you go. Technology is all great, but just dropping a platform like this in the organization is not really desirable, because you'll find a lot of people not knowing about what streaming is, and just dropping the platform will certainly lead to disaster. So there's a lot of guidance available around the platform, guidance for teams that want to connect to the platform, but also guidance for teams that need to manage a platform like this. And this is really where the partnership also with LINKIT comes in. This is something we can jointly help you with, the types of services along with the technology to really guarantee the success of a streaming platform in your organization. And with that, I would like to see if there are still any questions.
Yeah,
Yes.
I see a question coming in.
Oh,
from, maybe the first one I can take from Sai in Sin. In this case, the Telegram message was a custom the custom IDs used for in the setup of this demo. So there's no, like, let's say, automatic integration with Telegram built in the platform. I hope that answers your question. And maybe Jeroen, you can comment to Dan's question.
Yeah, I'm scrolling back. So Dan says, if a company wants to start with data streaming instead of batch processing and they think they have a good use case, what would be the best approach to start and what is next? What do you need to have in place? So if a company wants to start with streaming, I think the first step to take is to really see what type of application is producing or consuming, and try to model it as simple as possible. It's really easy to hook up a streaming platform nowadays. It used to be more difficult, but it's really easy to just set a first step, produce a message and start consuming it, and see if that helps in your use case. So the first case we did for the first customer that we have in banking was the alerting case. So that was really the first data stream that we hooked up. It was all the payments on all the payment accounts, all the booking on all the payment accounts, hooking that up to a mainframe and then seeing if we could do alerting based on those. And then we learned a lot as we went along. This is why I also closed off with the slide that I just did. It's really taking small steps. Because streaming is new for a lot of organizations. So you just need to start experimenting with it. And you see a lot of people in the organization and DevOps teams, they need to build their own mental model about what data streaming actually is, how it works, and what it can mean to the organization. So select the first use case, try to define an event that you want to share between applications, and just start with it. And you'll find out that this mental model is really going to shape as you implement that individual use case. Let's see if there are any other questions.
I see that on that question Don also asked me, but this is the actual part, and I would like to highlight one thing. You can download the Kafka binary and run on your things, and you say, "Yay, I have it working." But if you talk up with Axual and the banks and the things that we have implemented this, you see the benefit of actually using a platform like this, because having that working with a TLS, managed services, all of it, all out of the box, it's extremely cumbersome. There are so many moving parts. So if you want to start data streaming as a POC and you want to get Kafka binary and play around with it, that is okay. But to convince your architect to put that in production, that is a different thing that you get with Axual and other things. But what I would like to say is that first, if you have the business case for the streaming, that is perfect. That is the trickiest thing to find, because a lot of clients that I go, they want streaming for the vanity metrics. Like, I want to have a dashboard with real-time data. Okay, can you take actions on that? No. Oh, then it's not very much of a use case. So if you take that out and you have an actual business case, yes, come and talk with us and with Axual, that we can make it a real nice POC. But having the business case is the most important thing.
Yeah. I see also a question from Hans Reiterink. Could you explain in what ways the Axual platform is different from a managed ESB in the cloud? I think what a streaming platform, what sets apart a streaming platform from an ESB is that a lot of ESBs are containing a lot of logic. So you'll see ESBs doing routing, transformations, conversions, and this is really what makes ESBs, almost part of a business application, because a lot of knowledge about the organization is being put in the ESB. And historically, we've seen that generates highly inflexible landscapes over time. What you see with DevOps is that everybody is moving into DevOps. It's the speedboats around the oil tanker, and these speedboats need to operate quickly. So that means they need to be independent, and they need to be able to interact with the mothership, but not being dependent on its speed or on its course. And this is also really what sets apart the technology on streaming with ESBs. ESBs try to solve a lot of things, where streaming is just message passing in real time on a very big scale. And if you model these messages as the events of something that took place, then it becomes really message passing at high speeds at very large scales.
Yeah. So you would say that when you adopt streaming, you should move the logic from the ESB to the consumer and accepting applications.
Yes.
That's the consequence of it. Yes. Okay.
And what a streaming platform also does is it builds upon the publish-subscribe pattern. So ESBs can also support this, but for streaming, it's just the core of what they do. It's only publish-subscribe, so there's no interaction between the producers and the consumers, other than the data being passed.
Yeah, thank you.
Let's see. Patrick says, what I missed in this presentation. Christian, interrupt me if I need to quit, because otherwise I'll just keep on answering questions. But what I missed in the presentation is the protocol as the decoupling of tooling and functionality. For instance, MQTT and MQP are streaming protocols by nature. Yes, they are. What you'll also quickly find is that streaming platforms have all kinds of interfaces to MQTT or other protocols. But what they do is they act as a message broker between parties. So on a technical level, it's the publish-subscribe pattern that is really implemented on a very large scale. And that's what we also implemented in the core of our platform. Not sure if that answers your question.
Yeah, that answered it. It was a nice presentation, thank you. But I just noticed, well, maybe as an architect, I'm used to work from the protocol down. And if you use MQP, there is streaming. So to me, streaming is more like the topic hierarchy, and which kind of tool is behind it, or tools or producers, is less important when you base everything on protocol. That was my...
Okay. Yeah, well, what we see in organizations is more that it first starts out with use cases, and the use cases need to interact somehow. They have different applications that need to interact. You need to couple a mainframe to your SAP, or you need to couple your marketing automation to some email framework. And then you start wondering about, how can we make those applications interact? And then you come into streaming arena. So we often see the other way around, that you start with the use case and then go down to the protocol part.
Yeah.
Question from Daniel. In this case, event system, indeed, Kafka is to the core of our platform. Let's say we did not pay a huge amount of attention to that, because as Jeroen said, we really want to approach it from use case down to the technology. We put this layer on top, the enterprise layer on top, to make it easy to manage the data streams, to make sure that only allowed parties have access to the data, etc.
See, question of maybe one I skipped. How does Axual differentiate itself from ESB or other streaming platforms like Apache Kafka? We have Kafka at our core, so we are fully Kafka compatible. We just find that a lot of organizations, when they start with streaming, they run into these difficulties around the personas that I showed in the presentation. Because data governance and security, there's mechanisms in Kafka, but if you have to figure them all out and then implement them, then for a big organization, it can take you over 2 years to do so. So we just built a fully installable platform around Apache Kafka. But if you have applications that connect to Kafka already, you can easily hook them up to our platform because it's the binary protocol that we talk under the hood. I hope that answers Gerard's question.
Yes, it does. Thank you.
Maybe do 2 more, one from Wouter and Erik out Ammerveld, and then...
Yeah. So Wouter is asking what kind of protocol is used to connect as consumer to the Axual platform. Can it easily be connected to common BI tools as Power BI? Well, as said, we use Apache Kafka under the hood. So a lot of applications already have Kafka connectors. But we also support custom connectors to all kinds of different platforms. So for instance, to hook up a database to do change data capture, so that every change in a certain table is being reflected as a single message on the event streaming platform. That can be done. There's also possibilities to couple with REST. So there's a REST API that you can call to produce or to consume a message. So there's all kinds of protocols. I think the protocols are not necessarily What makes the platform function? I think the protocols are just a means to get data onto the platform. And we support all kinds of protocols to get the data on the platform and off it again.
Thank you, that's clear.
Okay. There was one more question you said, Joris. Which one was that?
Yeah, from Eric. Did you apply a streaming model to distribute data globally too? Well, we created indeed a component to make this possible. We conveniently called it distributor. So it has ways to distribute data over multiple clusters and multiple levels. And you can have those clusters running in, in availability zones or regions across the world. Right now we are focusing in Axual Cloud. We're focusing on the west of Europe. So we have a region in Amsterdam, a region in Dublin in this case. But you basically can scale this, virtually unlimited. Of course, truly unlimited is not possible, but you can scale this very much to a larger level, larger amount of clusters that are distributed more globally.
After the session, we will also share the slides. So if you're interested, you can took a look at the platform components and features slide that was in the presentation, and it will maybe give you some more insights into what kinds of features are incorporated in the platform.
And then I think it's time for the last question from Sahin, and then we can go to the next presentation.
Yep. So I see, given the following, the business case is clear regarding data streaming. It's approved by the board to start with this. What's the best practice to start with a data streaming project? Does it differ with normal IT projects, waterfall, etc.? I don't think it matters, it differs that much to normal IT projects. What you see happening a lot is that if you start implementing, a single use case, then you'll find that there are many different streaming platforms out there. So you have, your SaaS offerings like Kinesis, like Event Hub. There's all sorts of open source offerings like Pulsar or Kafka or maybe even RabbitMQ. There's also proprietary offerings from the TIBCOs and the IBMs of this world. So there's all kinds of options that you have within your project to do so. What we see often is that once a use case hooks up to a specific streaming component, then over time a second use case will come along that also needs to be hooked up, and a third use case will come along that also needs to be hooked up. And in the first use case, you'll not care too much about security because everything is under your own control, and you don't care too much about data or data evolution because everything is under your control. But over time, this implementation grows and grows, and especially in organizations that are really speeding up in terms of response to the customer or response to sensor data flowing in. So what you'll find is that an initial choice for a streaming engine may become too limiting because you really need to control and the security and the governance around that streaming engine to be able to scale it up in the organization. So the best practice would be, start out with whatever you would like, but do think about the future. And as soon as you'll experience streaming as becoming too limiting because you need to do a lot of technical maintenance tasks yourself, then I suggest, well, maybe you come get our more detailed presentation because we have terrific solutions for that.
Okay, yes, thank you. Just a quick message we've got from the breakfast company. People who didn't get their breakfast, maybe you didn't hear the doorbell ringing because now it's on your doorstep. So after the last presentation, you can go and grab your breakfast as well if you didn't receive it. And then I think now it's time for the last presentation. We know a lot more about the concept right now from real-time streaming data and know a little bit about what's going on behind the scenes. And then I think now it's time to put all this knowledge into practice with the final presentation from our Principal Data Solutions Engineer, Alyona, for a presentation about real-time streaming in a data factory, or in a factory using a lot of sensors and data. And for the vegetarian people among us, she promised not to go really in depth about the factory's products. Maybe you think about input chicken, output really small chicken parts, and I think we know enough. So Alyona, take your stage and give us a nice presentation. Enjoy.
Okay, thank you so much. Let me share my screen first.
Hello. Hello.
Hello. Okay. Okay, now. So, hello everyone. Thank you so much for joining the session. I hope for those who got their breakfast, they enjoyed their breakfast. Also, big kudos to the previous speakers. Thank you so much for sharing a lot of useful information. My talk, although the name Reducing Production Waste with Streaming Analytics, it sounds like it's applicable only for manufacturing companies. Actually, it's not, because all things that I will talk about further can be easily generalized to your own business. So why this thing? Why this particular topic? This is a project that I really love to work for due to its complexity, but the results were really, really rewarding. So let's start. Okay, so the problem was I had a client. This is a food processing company, and they have 10 food processing facilities. Each facility is equipped with different machines that emit a lot of data. Think over like just basic temperature, humidity sensors. And as Christian mentioned, so as an input, we had raw ingredients, raw food ingredients that should be processed. And the output, we get processed ingredients that can be later distributed by a large supermarket chain or other food warehouses. And despite doing really great regarding their figures, what the company noticed that they do not really great in comparison to their competitors. And they were looking for a way to improve not only their costs, but as well their operational structure. Also, what they noticed that although they aggregate some costs based on some parameters, they noticed that maybe they do something wrong because there were two costs that were, let's say, dominating the rest of it. It was the production waste costs and predictive maintenance cost. On top of it, the company experienced, let's say, outdated and siloed information flow. What do you mean by that? So each food processing facility has its own managing director. This person is responsible for sharing all sorts of data with the head office, but they do it in a batch manner and a really old way batch manner. So we had quarterly reports. Imagine quarter is over, then within 15 days, the report is sent to the head office. So the head office is responsible for collecting all these 10 reports, and the data analysts were processing them and were compare as well the actual figures with the planned figures, and as well some, let's say, nice looking visualizations were created. And on an annual basis, the managing directors were flying to the head office to discuss what to the next step, what to do next, and to plan the budget and discuss the results of the previous year. So it looks like they have some information flow in place. It looks like they know something about their cost, and they heard that maybe streaming analytics, oh, this, two big words can help solve their problem, maybe reducing costs or become more flexible in taking decision, or maybe lowering cost of production waste, or maybe lowering the cost of predictive maintenance. It was not clear in the beginning. So now let's start the streaming journey together. Wharton notice, it's actually not a super technical talk at all due to NDA, but these steps, I think, once again, are applicable to almost all companies. So the streaming journey always begins with something. Today, we heard a lot of time that we say first has a use case. But before just having the use case, you need to make sure that if you want to be a data-driven company, the data should be part of your strategy. Nobody wants to collect data just in the sake of collecting data. Nobody wants to have streaming data just in the sake of having streaming data because the competitors have it. So only if you can acknowledge, together with your executives and stakeholders, the data from this day will be part of your strategy, you can do something. As well, derive value from your data. Imagine you have a streaming platform, everything in place, you collect tons of data, and what next? Why do you need all this data? What kind of value can be extracted from it? That's why we go to the use case. So if you have use case, you can understand what type of value, what type of data to look for. Replace top-down approach. This is easy to say, but really, really hard to implement. Because usually all this transformation are made in top-down manner. When they say, okay, from this day we are a data-driven company, we have this nice looking plans, this is what we'll be doing. But nobody listened to people who really do their job. Nobody listened to the maintenance people or operators who really knows their thing. And iterate and act on feedback. As I mentioned before, it's not possible to roll out immediately to the whole company, especially the bigger the company, the harder it is. And when I say act on feedback, I put it here by intention. There's a lot of company collecting feedback because, yeah, it was said in the book that we need to iterate, collect feedback, but nobody wants to act on this feedback. And even if you're collecting tons of feedback, you generate a lot of data again, but you don't use it, then you lose a lot of money without any actionable results in it. So this is the basic steps, but it's really, really, really important to know about them and not to overlook them. So let's get back to a food processing company. So the first step, decide to have data as a part of the strategy. Some decisions were really hard decisions were took, and they say, okay, from this day, we can do prediction based on this, based on the data. And they had a really, really long conversation with managing directors, what is important, what to amplify, where to focus. But let's say the draft of strategy, how to use data was set up. The second, derive value from your data. Let's get back to the fact that we need a use case. In this case, we say, okay, we know that reducing production waste, this is the biggest issue for us. But do we know the real impact of the production waste? Do we really aggregate all costs appropriately? Do we really know that all these costs belong to this particular production waste stock? Let's start investigate from this part. And then what data do we need? What value do we want to extract? Remember that we are a food processing company. It means that we have perishable goods. So in the case with production waste, when we start investigating what we learn for, before, only the cost of really spoiled and perished products, ingredients, were taken into account. But nobody calculated if you need to get rid of these products, if you need to get rid of these ingredients, it also involves cost. On top of it, you have cost of unfulfilled promises to your customers. On top of it, you need extra stock to process again. So there are a lot of things. And when you start to dig in deeper, you can have a lot of insights based on that. Regarding replace top-down approach, it was actually one of the hardest parts in the whole set. Unfortunately, one of the managing director left his job due to this, but it was really good that he found another person to do the job in more elegant way. And based on this, they decided to really listen to their workers. The issue was that we have 10 facilities scattered all around the country, and we have only one maintenance team. And this maintenance team was always overflooded with all the messages. We need you here right now, or no, go here, no, go to this, no, this machine is idle, we need to start this. So it was unclear what to do, where to go, and what really needed to be fixed. So only listen to these people and understanding what type of data can alert where it's really urgent situation, what type of data can say, okay, it's not so urgent, it can wait. So even some information that we get from these people allow us to prioritize the maintenance cases. And iterate and act on feedback, we decided to work on a 2 weeks cycles, and with when each cycle is ended, just to evaluate what happened. Are we going in the right direction, or we need to stop? And act on feedback, once again, listen to people. They know best. Only the people on the production line knows what's happening there. So what was the end result of all this? First, we set up unified data collection. It was really hard to do because we have 10 different facilities with different types of machine, different age, with different elements. And some of the machine produced one specific types of data, another would produce different types. It was really hard, but thanks to listening to all people, and especially for operators from machine maintenance team, we can get to it. And then the processing setup. It was as well really important to listen to all parties to understand what to prioritize and what need immediate attention, what not. Information flow was improved. So before we had this, let's say, really old batch case of information. First, we moved to the monthly basis. Then we moved from monthly to the week basis. And the last step was to move from the daily basis, almost, let's say, to hours second basis. As a result, the production waste reduced up to 87%, and it was really unbelievable results. In the beginning, it was not clear, but when we fully understood what is belonged to this production waste, it was much easier to solve. And as a nice side effect, we get a maintenance cost reduced up to 58%. Why? Because the maintenance team know where to put their attention and which machines really need their attention. On top of it, using the sensor data, we know when to start fixing the machine before it can create much more problem. And of course, the employees' happiness increased endlessly, because when you know that you are heard, then the people who are upstream are listening to you. It gives you a lot of possibilities, a lot of feedback, how to improve the stuff that already existed. So I think that's it from my part. In case of any questions, please fire up. Thank you.
Yes, I think we've got one question. You see them as well, Alyona?
Yeah.
Okay.
Yeah, how do you change from top down? Yeah, it's a really good question. It's really hard, especially the bigger the company, the more implications it has. I think first, start small, literally small. You don't need to be CEO or director of the operation to do some stuff. You can easily say, okay, look, this is my experience. This is what I have. I see the problems that we have. This is what can be improved. And to improve this, I need this kind of resources. And then talk to different people. If one person doesn't listen to you, talk to another people. Always be active, because only on this you can start moving. And also you need to understand that if you're not starting doing something right now, you will be a way back behind your competitors. As with this company, from one side they say, oh, we got all these facilities, we're doing great. From the other side, it looks strange because the competitor is doing better. What their advantages? Why do they do this? Okay, they have lower cost. Why do they have lower cost? And then you start like untangle the big like part of information. You start cut into small pieces, and you get something from it at the end. But once again, it's really hard, and only if you really want to change something, yeah, you can do it. But if you just want to pretend that, okay, I'm good as yeah, no, then good luck, and no platform can help you in this.
Thank you. Do we have other questions? No. Oh, one more.
Yeah, it's like a cultural shift as well, right? Yeah, right. Because actually, you know, as I mentioned before, one of the managing director left because this person just want to be transparent. The more you go, the more transparency you get. Because with streaming data, there is no possibility, let's say, to forge the numbers. This is the issue. It's like an open space. So you see the results, you see immediately how this particular department is performing. And for a lot of people, it's still a fear to being caught, or the fear to actually to tell the truth and to say, okay, this is a problem. We need to concentrate our efforts on it and not just, you know, let's slip it away. What is your role normally in such project, Alyona? Yes, it's a good question because usually it's more like something in between. I do a lot of technical stuff. For that particular project, I was working as a machine learning engineer, and I was responsible for setting up all the streaming part. But because of my managerial experience, I used to be like an analytical translator, you can put it this way, and help the company to come up with a proper use case, and help the company a little bit of product owner job as well, to split it in chunks and to see how to prioritize and where to concentrate the efforts. Yeah, but it can be anything. Because what I notice, there are a lot of brilliant people that are really good technically. There are a lot of brilliant people who are really good as managerial position, but the world needs people like me who can be in between. So that's why we can bridge the gap. Thanks.
Okay, one more round. Do we have any questions for ASML, for Axual, for Alyona as well? You can now, if you have a question, also unmute yourself and just ask them, not through the chat. No?
I have one quick question
Oh.
for Axual is about the demo, and if I want to start to using the cloud, do you have like a trial version for the people that want to play around with it?
Yes, it's possible to get trials. So if you maybe you can contact us directly or through the organization of this ONTBITES session, you can easily find us, and we can arrange you with a trial. That could also maybe support a first use case that you want to set up.
Okay, then now I think we're kind of at the end of the second breakfast session. I would like to thank. Oh, do I hear myself?
Sorry, I was unmuting.
Oh, okay. Yeah, well, I would like to thank everybody who, for all the speakers, our amazing lineup, as I really like to call it. And thanks, Carmen, for arranging the lovely breakfast for every one of us, and for everybody who was here, for asking nice and questions to make it an interactive session. Personally, I learned a lot. I hope it's for everyone. Now, for the last time, I will share my screen once more. Yep, that's that we're back in August with not a regular breakfast session, but with 2 shorter summer sessions. Think sunshine, flamingos, cocktails, virgin cocktails. We're doing it a bit shorter at the end of the day, and one with more on a data perspective and the other on an OutSystems part. But we'll get back to you with the slides of and recordings of this session, and we'll also introduce these 2 summer sessions as well. One more thing about the slides and the recordings is that we only can, that was a small fault of mine, that we can only get back to you with the slides from Axual and LINKIT, but not with the ASML part. And then at the last thing is, again, thank you. My contact details are on these slides, and if you want to reach out, have questions, I can make sure that you get in contact with the right person. And have a nice day, have a nice working week, and hope to see and speak to you soon.